So today we are reviewing factoring. That's our first section. I have them split up into their different types of factoring problems. We'll do a couple of each type. Number 1, factor the GCF. 8x squared minus 14x. So we're finding the term we can divide both 8x squared and 14x by. And that would be what? 2x, thank you. 8 and 14, the largest number we can divide both of those by is 2. Anything higher, we're going to end up with a decimal of sorts. And then the x's, we can take out the smaller one of the two. That will always be the case, so we can take out x. Reminder, when you pull out a GCF, it comes out, but it doesn't disappear. So make sure you put it on the outside and then introduce parentheses. Once you do the division, that leftover is going to go inside the parentheses. We have 8x squared over 2x. 8 divided by 2 is 4. X squared over x. Remember, when we divide the same base, when we divide variables, we're just subtracting their exponents. 2 minus 1 gives us just x to the first, or x. Minus 14 over 2 is 7. And we have an x on top and bottom. Those will cancel, so it's just 7 left behind. Questions on that? Excellent. Number 2. 5x cubed y minus 3xy squared plus x cubed y to the 5th. Finding a GCF. First off, let's take a look at the numbers. Our back term has a 1 in front of it, so automatically we can't pull a number out of all 3 of these. So we look at the letters. All 3 of them have x's. The smallest x term is just x, so we can only take out an x out of all 3. For the y's, we have y squared, y to the 5th. Again, we can only take out y. So our GCF is xy. And then we put the leftovers in parentheses. The 5 in the first term will come down. X cubed over x to the first, we subtract these exponents. 3 minus 1 is 2, so we have x squared. Y over y, those are going to cancel. We have 1 on top and bottom. Bring down the negative 3. X over x, those are going to cancel each other out. Y squared over y to the first, we subtract the exponents, and we have y to the first, or just y. Lastly, we have a 1. I'm not going to write 1 down. Start the plus. X cubed over x to the first, subtract the exponents, and we get x squared. Y to the 5th over y to the first, subtract the exponents, we get y to the 4th. And that's all we can do. Questions on number 2? Okay. Next category, difference of squares. X squared minus 9. When I factor it, what is the answer? I'll give you a hint. We have x's in the front. That's pretty standard. Devin?
X plus or minus 3.
Yep. We have an x plus 3 and an x minus 3. For those of you who don't remember how those work, difference of squares, we look for 2 perfect squares being subtracted, hence the word difference. So perfect square minus perfect square. Square root of x squared is just x. And then 9 is a perfect square. Its square root is 3. Square root the front, square root the back, leave out the negative. You know that we can't square root a negative. We get imaginary numbers that way. And then we write our factors like so. Number 4, also a difference of squares. 16x squared is a perfect square. And 25 is also a perfect square. Set up 2 factors always. I'll do the front first. Square root of 16x squared is 4x. That goes in the front of both of those. Square root of 25 is 5. That goes in the back. One of them gets a plus, the other gets a minus. Those are your factors. Questions on difference of squares? Okay. Next section, the trinomial factoring. Probably what comes to mind most when you hear the word factoring. 3 terms. They're of the form ax squared plus bx plus c, ABC. We're going to use those in a moment. So first semester, we went over how to do this. I taught personally the slide and divide method, the ACB chart. It depends on which problem, depends on what I call it, but it's that. Did anyone come from Honors Algebra 2 in here? Good.
Yeah.
Yeah? Oh, I forgot you did. Yes. So you guys were shown guess and check in that class. If you do guess and check, that's fine.
Yeah, but I thought it was dumb. I did slide and divide.
Good. Perfect. Then do slide and divide. But yeah, I'm going to be doing slide and divide. So if you prefer guess and check, you can use it. All right. ABC. Our A here is 1, so this is going to be a very straightforward problem. First off, I like to set up my factors just like a template. X's go in the front. And then we make an ACB chart. And then this is A times C, just to clarify. A here is just 1, so 1 times -6 will give us -6. And since this value is negative, we're subtracting to get this number on the right side. Our B value is -5. This helps take some of the guesswork out of it. Whenever your numbers are 6 and 5 like so, I always recommend considering both pairs of factors because it could be 1 and 6 or 2 and 3. It just depends on the signs. So I'm going to write out both pairs. 1 and 6, 2 and 3. Since we're subtracting for this problem, the only way to get a 5 is if we do 6 and 1. Subtraction will end up with a 5. 2 and 3 will end up with 1. So it's not going to be 2 and 3 this time. To get -5 out of this, the 6 must carry the negative. 1 minus 6 is -5. 1 and -6 are our factors. Plus 1 minus 6. And there's our answer. Questions on number 5. Number 6, 7x squared plus 23x plus 6. First thing you should look for is a GCF. That's something I'm kind of bad about harping on, but it is important. There is not a GCF here. 7 and 6 clearly have nothing in common, so we can stop our search there. Here, A is not 1. I'm going to emphasize that. I'll come back to that point later. That is going to make this problem a tad more complicated. Label ABC. We'll make our factors. Again, you always have your x's in the front. ACB chart on the side. A times C, 7 times 6, that's 42. And that's positive 42. So we're adding to get that number on the right side. B is also positive 23. 42 has a lot of factor options. I'll go ahead and give you what we're looking for. 2 and 21. 2 times 21 is 42, and when I add 21 and 2, I do get 23. Those are the two numbers I'm looking for. So it's plus 2 plus 21 for my factors. I hope many of you can see that I am not done, because if I were to multiply these back together, I would not end up with the original problem. For starters, if I multiply x and x, I'm not going to get 7x squared. There's not a 7 in there. So how do I handle this from here? Devin?
You gotta divide the 2 and 21 by 7.
Correct. So this specifically is called a slide and divide problem because our A value is not 1. And that's where the name comes from. We divide both factors that we get by the A value, which is 7. And then we slide or divide from there. It depends on what our numbers are. first set of parentheses, 2 divided by 7, that's clearly a fraction, a decimal I mean. So slide the 7 in front of the x. We have 7x plus 2. 21 over 7, that's just 3, so we'll divide in that case, and we get x plus 3. 7x plus 2 times x plus 3 is our answer. And again, that one was specifically slide and divide. Questions on number 6. Moving right along, factor completely, number 7. When you see those directions, that especially is a hint to look for a GCF. Usually these are a combination of things, GCF and trinomial, GCF and difference of squares. We like to throw everything that we can at you first. 5x squared plus 5x minus 10. I hope that the GCF is really obvious. It's 5. So we can divide all of these numbers by 5. 5 comes out. 5 over 5, that's going to cancel. We're left with x squared. Plus another 5 over 5, that will cancel, leaving us x. Negative 10 over 5, that's negative 2. From here, inside the parentheses, we have a trinomial that we can factor, so we'll factor that. 5 is just going to come down and be part of the final answer. I'll set up my factors here. We have x's in the front, of course. ACB charts to figure out what those factors are. When you do ABC, do it from the one that has been factored the GCF out of it. If you do it from the original problem, 1, it's going to be wrong, and 2, it's going to completely just negate the whole purpose of pulling out a GCF. We have A times C, that's 1 times negative 2, so that's going to be negative 2. And since this is negative, we're subtracting to get that number on the right side. Our B value is just 1, and it's positive 1. 2 only has one set of factors, 1 in itself. And I've already emphasized we're subtracting. That's the only way to get 1 out of those two numbers. We want positive 1, so it's going to be 2 minus 1 will give us 1. So my factors are negative 1 and positive 2. That's all I can do. That's my answer. Questions on number 7? Number 8. 2x squared minus 6x minus 16. Again, look for the GCF. Hopefully it's obvious we have 3 even numbers here. So we can pull a 2 out for sure. So we have 2 times. Dividing, we end up with x squared minus 3x minus 8. And now we have a trinomial that we can factor. I'm going to create our factors down here. 2 just comes along and it's part of the answer. We have ABC. Making our ACB chart. A, again, is just 1, so we have negative 8 for our C value. Since it's negative, we're going to have subtraction to get that number on the right side. And then our B value is negative 3. Hopefully looking at these two numbers, you can already tell that this is not going to work. If you end up with that kind of problem, I need you to exhaust all options. Show that you actually looked and tried. Because there are plenty of times where it works and students just give up too quickly because they didn't think about the answers fast enough. So if it didn't come immediately to their mind, it must not work. That's not always the case. Write out your answer or your options and show that they don't work. I'm going to demonstrate here. 8 has 2 pairs of factors, 1 in itself and 2 and 4. So if it's going to work, it's going to be one of these 2 pairs. We're going to subtract, and we need a negative answer. So that means the larger number in each pairing must be negative. That's how we get negative numbers, negative answers. 1 minus 8, that's negative 7, not what we're looking for. 2 minus 4, that's negative 2, also not what we're looking for. Those are my only options. So in this case, my attempt at factoring failed. So I can't break it down that way. The answer above, where I just pulled out the GCF, is as far as I can go. This is my answer. Questions on number 8? All right, go ahead.
You wouldn't do the factor equation or
Factor equation. Are you talking about quadratic formula?
you quadratic formula? Wouldn't do that to figure it out.
That would be if I were just trying to find the solutions, but just factoring, like, and I'm only asked to factor, you don't have to go that far. You can, but you don't have to. Find each product. 3x plus 5 squared. Let me show you what we're not going to do. We don't distribute exponents. Nope, don't do that. Since that's not an option, what am I going to do? Split it up. That 2, that's how many times you're going to write that set of parentheses, so twice. So we're going to have 3x plus 5 times 3x plus 5. That's what it means to square something, multiply it by itself. And then we're going to FOIL, double distribute, whatever word you like to use. I use them interchangeably. So first we'll distribute the 3x into the second set of parentheses. 3x times 3x, that is 9x squared. Be careful with your exponents. 3x times 5, that's 15x. And then we distribute the 5 into the second set of parentheses like so. 5 times 3x, that's 15x. 5 times 5, that's 25. If you FOIL in the correct order, then the middle 2 terms can be combined. 9x squared plus, that will give me 30x plus 25. And that's as far as I can go. This is my answer. Questions on number 9? Number 10, just a distribution problem, but heavy on the exponents. So we're distributing 3x squared y into the parentheses. Got 3 terms we're going to multiply by. Remember, when we multiply the letters, we are just adding their exponents. That's all we're doing. 3 times 7, that's going to give me 21. X squared times x squared, that's x to the 4th. Y, and this is y to the 1st, times y cubed is y to the 4th. Plus 3 times 9, that's 27. X squared times x to the 1st, that's x cubed, and we're going to bring the y down as well. Minus 3 times 6, that's going to be 18. X squared times x to the 1st, that's x cubed. Y times y, y to the 1st times y to the 1st, that's y squared. That's all I can do. This is my answer. Questions on number 10? Okay, let's go to the back and do some fractions. We are going to go back to the very basics of fractions, like back in elementary school basic. Just a couple of directions. Perform the given operation without a calculator, and I say that because the kind of problems we're doing in here, you can't put into your calculator. All answers must be fully simplified. We are in pre-cal. I don't think it's unreasonable to expect that everything be fully reduced. If it's not fully reduced, you're going to lose some credit. Number 11, 2/3 plus 7/8. So what's the golden rule when you add and subtract fractions?
Same denominator.
Same denominator. They must have the same denominator if you'll add or subtract. So get a common denominator. And I'm going to leave that and hanging there for a moment. We'll come back to it. So let's do that step first, number 11. 3 and 8. Usually we're going to just multiply those together. That's going to be our common denominator, 24. So I'll multiply 2/3 by 8/8, top and bottom, and multiply 7/8 by 3/3, top and bottom. That's how we're going to get that common denominator of 24. Making my new fractions, 8 times 2, I've got 16, over 8 times 3, I've got 24, plus other fraction, 7 times 3, that's 21, over 8 times 3, that's 24. When you get to this step, please resist the urge to reduce the fractions. I have seen it before. That would, again, undo the work we just did, so don't reduce it. How do I go from here? What's the rule for adding? Yeah.
So straight across the top and leave the denominator?
100% correct. Add only the top. Leave the denominator alone. Don't turn it into a 48. So 16 and 21, that's going to get us 37 over 24. Keep the denominator the same. Now, if you're able to, check it with a calculator. That'd be fine, but I need to see the work on your paper. So let me add to those directions here. And add / subtract, it depends on the problem. Only the numerators. Don't add the bottom two. (37/24). I think it's pretty obvious it doesn't reduce because 37 is a prime. We don't see it very often. It's only got 1 and 37 as factors. Though I do want to show you kind of a pro tip with the calculator. If you type a fraction into this calculator and hit enter, it will reduce the calculator for you if it can. So I'll demonstrate. I'm not going to do 37/24 because obviously that's not going to reduce. I just told you that. So let me get one that will reduce. If you have my calculator, it's alpha x for the fraction shortcut. Hopefully you remember how to do that from last semester. Let's go 24 over 64. That will definitely reduce. And as you can see, it popped out another fraction. And of course, it's not going to focus. Hang on. 3/8. So it reduced it for me. So that is a really neat feature of this calculator. It reduces fractions for you. If that's something you struggle with or you just want to make sure that it's right, use the calculator. Number 12, 1/2 minus 5/7. Same procedure. Get a common denominator first. 7 and 2, common denominator would be 14. Times 7 over 7 on the left, times 2 over 2 on the right. Multiplying to get our new fractions, we have 7 over 14 minus 10 over 14. Again, subtract straight across the top. 7 minus 10, -3. Keep the denominator of 14. Can't reduce, so that's it. Questions on adding and subtracting fractions? 2 more. Multiply. I've already given you a little peek at this. How do I multiply fractions? What's the procedure?
You do across the top and bottom.
Exactly. Multiplication is the one that can do pretty much whatever it wants. Multiply straight across. top and bottom. No common denominator needed. Don't get a common denominator. That's going to make your life harder. So let's do that. 4 times 6 is 24. 5 times 7 is 35. You can try to reduce. It's not reducible. Last one, division. We actually did a little bit of this in the last unit, so hopefully you remember the rule for this. How do you divide fractions? You can explain it one of two ways. Keep, change, flip, yeah. That's how I like to say it. Keep, change, flip. Keep, change, flip. Some of you prefer multiply by the reciprocal. Those both work. But I like to say keep, change, flip. You're going to be doing a lot of dividing of fractions in this unit. So I implore you that you are careful when you do this. Don't try to do anything super fancy that can lead to mistakes. So what I recommend, anytime you get a fraction division problem, write it out as just a straight up division problem first. So 5/3 over 7/8. All right, 5/3 divided by 7/8. To make it clear as day what you're doing. Then I'll do keep, change, flip. Keep the 5/3 as 5/3. Change the division to a multiplication. Flip the second fraction. I have plenty of students when they try to do it in their head, they forget to flip the second fraction. That's the most common mistake I see. And then you just multiply like usual. 5 times 8 is 40. 3 times 7 is 21. Can't reduce. I'll leave it like that. And that's how you divide fractions.